The past is filled with darkness, mystery, and things that defy explanation. We're drawn to these stories, not to be spooked, but to understand what they reveal about us.
But sometimes the truth is weirder and creepier than fiction.
This is Down the Rabbit Hole, Weird History. I'm Rose Smith.
And I'm Jacob Wesson.
Join us as we explore the unsettling moments when human behavior pushes the boundaries of belief.
Let's dive in.
Tonight, we're going to Boston, January 1919, and we're going to talk about a flood that shouldn't exist.
Flood is water. You're telling me this is a flood of syrup?
Molasses. Thick, heavy molasses. A storage tank ruptures and a wave runs through the north end.
How big of a tank are we talking? Industrial. Millions of gallons. It sat near the waterfront in a real neighborhood. Tenements, small shops, kids outside, horses and carts moving freight.
So it wasn't isolated. People lived next to it.
They did, and that matters because familiarity dulls risk. A huge object becomes background. You stop asking what it would do if it failed. Why store that much molasses there in the first place?
Molasses was an industrial feedstock. It was used to make alcohol for a range of products, and the company running the operation, United States Industrial Alcohol, treated it like bulk inventory that had to move.
January 1919, so right after the war.
Right after the armistice, when industrial momentum doesn't just vanish. And this tank wasn't a quaint barrel. It was riveted steel plates forming a giant cylinder. Think of it as a metal stomach holding weight and internal pressure.
Pressure from what? It's a liquid.
From the sheer height and mass, and from gas. Molasses can ferment. If yeast is present, sugars break down and carbon dioxide builds up. That gas increases pressure inside the tank.
So the tank can quietly become a pressurized container.
Quietly is the word. And then you add winter conditions, cold nights, warmer days. Temperature swings change viscosity and pressure. They change how stress distributes across metal and rivets.
Okay, but there had to be warning signs.
There were. The tank leaked. People noticed molasses seeping out. There are accounts of neighborhood kids collecting the drips in containers.
That's nightmare fuel. You're literally scooping up the evidence.
It's also a clue about incentives. A company can treat leaks as nuisance losses instead of structural alarms, especially if fixing them costs time and money.
Tell me they didn't just ignore it.
The response appears to have been cosmetic. Painting a tank to hide stains doesn't improve integrity. It improves plausible deniability.
That's the creepy part to me. Risk management as camouflage.
Exactly. The horror is gradual, a neighborhood trained to accept a compromised structure as normal, while decision-makers treat it as someone else's problem until it isn't.
How do you even verify a tank like that is safe?
You test it. A basic approach is filling with water, bringing it to operating level, checking for leaks, monitoring behavior. You don't assume rivets and plates are fine because they look fine.
And if you don't test, you're gambling with everyone living nearby.
Yes. Now, picture the day it fails. Boston gets an unusual warm spell after colder weather. Warmth makes molasses thinner. If it's released, it flows faster. Warmth can also increase internal pressure.
So if it breaks violently.
And when it breaks, people expect slow molasses, but physics doesn't care about the name. A sudden rupture plus a massive volume can form a moving wall.
I hate the phrase moving wall.
You should, because it means there's almost no time to understand what you're in, and once you're in it, movement becomes difficult fast.
So we're not talking about a messy spill. We're talking about impact, force, and trapping.
Yes. Next, we'll reconstruct what the tank was doing in the days and hours before the rupture, and why a warning that everyone could see didn't become a prevention plan. Let's slow down on the mechanics, because this wasn't magic. A tank like that fails when multiple weak choices line up.
Weak choices like build it thin and hope for the best.
Or build it fast, skip independent review, accept chronic leakage, and place it where the consequences are externalized onto the public.
Externalized meaning the company keeps the profit, the neighborhood keeps the risk.
Correct. Riveted tanks can be safe, but they depend on plate thickness, rivet spacing, quality control, and a design that anticipates pressure and temperature variations.
And molasses isn't water, it's heavier.
Denser and more viscous. The hydrostatic pressure at the bottom depends on density and height. Millions of gallons means enormous load on the lower plates and seams.
So if the lower section is underbuilt, it's basically waiting.
Waiting and perhaps being pushed along by internal gas. Fermentation is a slow, ordinary process, but inside a sealed container, it becomes a pressure generator.
Would they have known that?
They should have. Even if you don't model it perfectly, you plan for headspace pressure and venting, and you track product conditions. The problem is when should have loses to ship it.
That's a familiar pattern in disasters. The schedule beats the checklist.
And chronic problems become normal. If a tank leaks and nothing catastrophic happens, it's easy to interpret that as proof of safety rather than a warning of fragility.
Like, it's been leaking for months, so it must be fine.
Exactly. That's a cognitive trap. Another trap is diffusion of responsibility. Who is supposed to stop operations? A foreman? A manager? The owner? The city? If nobody is clearly empowered to shut it down, it keeps running.
So the system is designed for keep going.
And keep going it did. The tank received shipments, was filled, and sat with product that could change over time. Then, weather matters. Cold thickens molasses. Warmth thins it. The same volume can behave very differently depending on temperature.
Which makes the molasses is slow assumption dangerous.
Right. People imagine a sluggish ooze, but if the tank ruptures, the initial surge is driven by gravity and pressure. The front edge can move quickly, and the depth can be enough to knock down structures.
What were the surroundings right there?
Streets, buildings, an elevated rail structure nearby, and a busy urban environment. A wave doesn't just spread on open ground, it slams into walls, pushes debris, and turns the street into a churn of material and obstacles.
So even before you talk about trapping, you're talking about blunt force.
And then trapping. Molasses is sticky. It clings, it drags. It makes ordinary steps feel like you're walking in wet cement that wants to keep you.
That sounds like panic in slow motion.
And panic isn't the key issue. The key issue is energy and viscosity. A person can fight panic. A person cannot fight a fluid that adds resistance with every movement and hardens as it cools.
So the longer you're in it, the worse it gets.
Yes. Now, on January 15th, 1919, around midday, the tank fails, and witnesses describe a loud roar, like a train, like an explosion, because a structural rupture releases stored energy.
It isn't just pop, it's catastrophic tearing.
Plates buckle, rivets shear, seams give way. The contents are suddenly free, and the street becomes the path of least resistance.
Do we know how high the wave was?
Accounts describe it as a wall of molasses, many feet high, moving with force. Whether a specific measurement was exact in the moment matters less than the outcome. It swept streets and buildings, and people had almost no warning time.
I keep thinking about the kids who collected the leaks. They're the perfect symbol of how normalized it was.
They are, not because they did anything wrong, but because they act like children do. They treat the world as stable. Adults are the ones who are supposed to assess instability.
So the setup is a dangerous object, inadequate safeguards, normalized warning signs, and a day where conditions make the failure more violent.
That's it. Next, we move from the lead-up to the moment of impact, what the wave did to bodies, buildings, and the city's immediate capacity to respond.
When the tank ruptured, the event wasn't sticky, it was violent.
That's hard to hold in my head. Molasses feels like something you drizzle, not something that hits you.
And that mismatch is part of why people were vulnerable. The wave surged into streets, knocked people off their feet, and pushed debris like battering ram material.
Debris like what? Wood, metal, whole pieces of building?
Pieces of the tank, structural fragments, fences, carts, anything in the path. A flood in a city is never just liquid. It's liquid plus everything the liquid can pick up.
So it hits you, and then it keeps hitting you with stuff.
Yes, and then the second phase begins. The flow slows, the depth remains, and molasses does what it does best. It grabs.
People and horses trapped in syrup.
Exactly. Horses were common in transport. They had mass, they had strength, and they still got pinned. That tells you how the material behaved. Not like a splash, but like a clamping medium.
If a horse can't pull out, a person doesn't stand a chance.
A person has less leverage, less power, and more vulnerability to cold. Remember, it's January. Even with a warm spell, it's still winter air, winter ground, winter wind.
So you're soaked in sugar sludge, and then the temperature starts working against you.
And as molasses cools, it thickens again. So the longer you're immersed, the harder it becomes to move. That's one reason rescues were so difficult.
What did responders even do? You can't just wade in like water.
Early responders included local police, firefighters, and nearby workers. They tried to pull people out by hand. They used ladders, ropes, anything that could provide leverage. But traction was terrible. The street itself became a slick, adhesive surface.
That's like trying to rescue someone from quicksand, but colder and heavier.
That's a fair analogy for the physics of resistance. And there's another layer, visibility. Molasses is dark. In chaotic conditions, you may not see where a person is beneath the surface, or how entangled they are with debris.
So you can't even find them easily, and every second the material tightens.
Yes, there are reports of people being trapped so thoroughly that rescuers couldn't distinguish limbs from coated rubble.
That's horrifying.
It is, and it's also predictable once you accept the material properties. The wave carried people into corners, against buildings, under wreckage. Then it settled like a heavy blanket.
How many people were hurt?
The disaster killed people and injured many more. Some injuries were blunt trauma from the initial impact. Others were drowning-like suffocation in viscous material. Others were hypothermia and shock.
So the cause of death isn't just one thing, it's a cascade.
Exactly. A failure like this doesn't offer a clean narrative. It's not a single explosive moment. It's impact, entrapment, exposure, and delayed rescue.
I'm trying to picture the city right after. The streets would be unusable.
Streets were clogged, buildings were damaged, infrastructure was disrupted. And because it's molasses, cleanup isn't pump it out. It's scraping, washing, dissolving, and doing it in winter conditions.
If you use water, doesn't it just smear?
It dilutes and spreads if you do it poorly. You need a coordinated approach, and even then it's labor-intensive. And while cleanup starts, investigations begin, because people immediately ask a simple question: why was this allowed?
That's where I'd be. Who signed off on that tank?
And those questions grow sharper when you learn that residents had noticed leakage before. Once there's blood on the street, what looked like minor seepage becomes a glaring missed warning.
That's where the creepiness becomes institutional, because it's not a freak lightning strike, it's a chain of choices.
Exactly. The moment after a disaster is when systems either protect themselves or confront themselves. Boskin did both. The city had to respond to victims and to a shattered neighborhood, and then it had to deal with accountability.
And I'm guessing the company didn't immediately say, "our fault."
Companies rarely do. Next, we'll follow what happened as rescue shifted into recovery and as the disaster moved from the street into courtrooms, where people tried to translate syrup and suffering into responsibility. Cleanup became its own ordeal, and it wasn't just about making streets passable, it was about reclaiming a neighborhood that had been physically coded in the event.
How long did it take? Like a few days?
Weeks for the major work, and longer for the lingering residue. Molasses seeps into cracks, wood, clothing, and the pores of brick. It's not a spill you mop, it's a contamination you fight.
And it's sugar, so it's going to attract everything.
Exactly. The cleanup tour swarms, flies, and other insects, despite the cold season. As temperatures shifted, the sweet smell persisted. People describe the area as sticky for a long time afterward.
That's such a specific kind of haunting. Not ghosts, just the scent that won't leave.
It also became a logistical problem. Workers used seawater to wash streets because they were close to the harbor, but water alone doesn't erase molasses, it relocates it. You're scraping, shoveling, washing, and repeating.
Seawater makes sense, salt and volume.
Volume helps, but even with a lot of water, viscosity and adhesion make removal slow. And while that work happened, families were counting losses and injuries, and the city was counting lives.
I remember reading it killed like 30 people.
21. And the number matters because it tells you how severe the event was without turning it into a myth. Overstating it turns it into folklore. The reality is already bad enough.
Right. 21. And injuries?
More than 100 were injured. Many had long recoveries. Some survivors carried trauma that never became a headline.
So then comes the blame game.
The search for cause, yes. And what's notable is that this disaster produced a major legal response. Lawsuits weren't an afterthought. They were a central battlefield.
People sued the company?
People, victims, families, and property owners pursued claims. The company's defense, as often happens, included arguments that tried to make the rupture seem unforeseeable.
Like an act of God.
Exactly. There were claims about sabotage, about anarchists. Remember, this was a time of labor unrest and political fear. Blaming radicals could be socially convenient.
So instead of "we built it wrong," it's "someone attacked it."
That's the pattern. But courts require evidence, not vibes. Investigations looked at construction, maintenance, known leakage, and whether reasonable care was taken.
What did reasonable care even mean back then?
It meant different things in different places, which is why this case mattered. The proceedings forced a detailed examination of engineering choices, plate thickness, rivet quality, testing practices, oversight. It turned an industrial object into an object of public record.
That feels like a shift. Engineering becomes something you can't hide behind jargon.
Exactly. And it's easy to forget how new that was. Today, we expect expert testimony, documentation, and standards. This case helped normalize that expectation.
Did the company lose?
The outcomes included findings that emphasized negligence and poor oversight. It wasn't just something happened. It was something happened because decisions were made without sufficient care.
That's the part that hits me. The tank wasn't a mystery. It was a set of choices.
And those choices were made in an environment where speed and profit were valued, and where the people at risk were not the people benefiting. The neighborhood didn't get a vote on whether to live beside that hazard.
So by the time it's in court, the real question is, will the system protect the company, or will it protect the public?
That's the question. And in the next half of this episode, we'll talk about what changed afterward, how this disaster fed into the evolution of inspections, engineering accountability, and the idea that industrial doesn't mean untouchable.
Because if a city can drown in molasses, it can drown in anything the system decides is acceptable.
We'll be right back with part 2.
Now would be a good time to hit those like and follow buttons, as well as leave a comment.
We need your help to continue bringing you stories like this one.
Now, let's get back to part 2.
When people say this disaster mattered, they don't mean it mattered because it was strange. They mean it mattered because it forced a change in how society treats industrial risk.
Because it made the invisible visible.
Exactly. Before the flood, the tank was a private object on private property, even though its failure would be public. After the flood, it became a public question. Who is responsible for proving safety?
And the old answer was basically, trust the company.
Or trust that the absence of previous catastrophe is proof. The lawsuits and investigations pushed toward a different answer. Safety needs documentation, independent scrutiny, and standards that don't depend on good intentions.
That's the birth of the idea that engineering isn't just building stuff, it's being accountable for what your stuff can do.
Yes, and it sharpened the concept of professional responsibility. If a structure fails, it's not enough to say, well, we didn't expect that. You have to show what you did to anticipate reasonable failure modes.
Like fermentation pressure, temperature swings, and maybe the most basic, whether the tank was actually strong enough.
Exactly. The flood fed into broader movements, building codes, inspection regimes, and a culture where engineers and companies are expected to follow established practices rather than improvising in ways the public can't evaluate.
So, is it fair to say this helped push the modern inspection expectations you see with boilers, bridges, and tanks?
It's one contributor. Disasters rarely create reforms alone. They accelerate shifts that are already underway. But this one was unusually vivid and unusually litigated. It produced records, expert analysis, and public attention that made it harder to pretend that industrial meant beyond ordinary rules.
And it's not just inspections, it's incentives.
Right. The flood is a case study in misaligned incentives. The company benefited from speed and storage. The neighborhood paid the risk. When you see that pattern, reform has to change the cost calculation.
Meaning, if negligence is cheaper than care, you get negligence.
Exactly. Legal liability changes that. When companies can be held responsible for foreseeable harm, the economic incentive shifts toward testing, maintenance, and safer design.
So the courtroom becomes part of safety engineering.
In a real way, yes. Tort law, insurance requirements, and regulatory standards become pressures that shape engineering decisions. They can be imperfect, but they create consequences that pure internal policy might avoid.
And what about the city side? Did it change municipal behavior?
It reinforced the idea that cities can't rely solely on corporate self-policing for large hazards. Over time, municipalities developed stronger permitting, oversight, and inspection practices, especially around structures whose failure radius extends beyond property lines.
The phrase failure radius is chilling.
It should be, because it forces you to picture the map of harm before harm occurs. A tank like that had a failure radius that included homes, streets, and lives.
So the big change is you don't get to build a bomb next to families and call it storage.
That's the moral clarity people gained, even if it took time to translate into policy. The flood also became a cautionary tale in engineering education, how small compromises compound, how warning signs get normalized, and how rare events are often just ignored events.
And there's something else too. It reminds people that disasters don't have to be exotic. They can be made out of everyday stuff.
Exactly. Molasses is ordinary, which makes the lesson portable. The question isn't what material is it? The question is what happens if it's released in volume, under pressure, in a populated area?
So the world changed by learning to ask the right question sooner.
There's a reason this story sticks, and it's not just because it's strange. It's because it shows how danger can be domesticated.
Domesticated like it becomes part of the neighborhood's normal.
Yes, a leaking tank becomes that tank. A sweet smell becomes that smell. Kids collecting drips becomes that's what kids do. And every day without catastrophe teaches the wrong lesson, that the risk is acceptable.
Until one day it isn't.
And then people act surprised, even though the clues were visible. That's the psychological creepiness. We're not afraid of the unknown here. We're afraid of the known things we choose not to take seriously.
It's the slow horror of paperwork not being done.
And the slow horror of authority being vague. If no one is tasked with saying stop, then stop never happens. That's a system design problem, not just an individual morality problem.
So if you were rebuilding that system today, what do you insist on?
Clear standards, clear accountability, independent inspection, documented testing, and an explicit rule that hazards with wide consequences are regulated as public concerns, regardless of property boundaries.
That's the part people forget. Private property doesn't keep the damage private.
Exactly. And we should also resist the temptation to turn disasters into legends. The Molasses flood gets told as a quirky Boston story, sometimes with a wink.
Like, isn't that wild? And then you move on.
But the human reality is grief, injury, displacement, and a neighborhood trying to live in the aftermath. If you keep the victims in view, the lesson stays sharp.
And the lesson isn't molasses is dangerous, it's systems that hide risk are dangerous.
Correct. The material is incidental. The pattern is enduring. Rushed construction, inadequate review, ignored warnings, and the belief that if something hasn't failed yet, it won't.
That belief is basically a superstition dressed up as confidence.
And it's encouraged by incentives. Speed is rewarded immediately. Safety is rewarded only by the absence of disaster, which is easy to take for granted. That's why accountability mechanisms matter. They reward safety proactively.
It also makes me think about modern infrastructure, tanks, pipelines, chemical storage, stuff people live next to without really knowing.
Exactly. The molasses flood is an early illustration of an ongoing challenge: how to make hidden systems legible and how to make decision makers feel the consequences of failure before failure happens.
So the creep factor is that it could happen again with something else.
It can. And when it does, the post-mortem often reveals the same phrases: known issues, deferred maintenance, no clear owner, testing wasn't required. There was pressure to keep operating.
Those are the ghosts, not the syrup.
Those are the ghosts. And even the cleanup detail: weeks of washing and scraping, the sweet residue, the insects drawn to it, works like a metaphor. The cost doesn't end when the wave stops moving. It lingers in labor, in health, in memory, in lawsuits, in new rules.
And in the next tank someone decides to build.
Exactly. The goal isn't to fear industry. The goal is to demand competence and transparency from it.
So the final image isn't the wave, it's the leak being treated as normal.
And the decision to ignore it because ignoring it feels cheaper in the moment. The rupture is just the moment the bill comes due, and the reason we keep telling this story late at night in a calm voice is to remind ourselves that calm is not the same as safe. Safety is something you prove, maintain, and enforce, especially when the danger looks ordinary.
Thank you for joining us in the rabbit hole today.
If you've got a story that defies explanation or just want to tell us how much this episode affected you, you can find us on Facebook, Instagram, and TikTok, as well as Spotify and YouTube.
Down the Rabbit Hole Weird History is brought to you by GX Works.
We'll be back next time with another deep dive into the parts of history most people would rather forget.
Until then, keep questioning what you know. Here is what we do know. The truth is always waiting just below the surface.
Be sure to like, share, follow, subscribe, and all that stuff to hear more episodes. Leave a comment to let us know what you thought and what you'd like to hear in the future. And we'll see you in the hole.